Hi, my dear students. I am Dr. Gsn Murthy, MA PhD, popularly known as Gsn. And I am having 51 years of teaching experience in competitive examinations and degree colleges. So, today's, for the sake of the rural and financially backward students, the government of Telangana introduced this program. So, now I am very happy to involve in this program, and my topic, today's topic is mathematics paper 2A, and the topic is complex numbers. And all of you know that the complex numbers is a very, very important topic in the mathematics, and the fact is until 18th century the mathematicians, they never touched the equations having complex roots. But in the 18th century, that Euler has introduced the number I, which is popularly denoted by the square root of -1. And then the subject is developed, and it has got leaps and bounds, the development is, and it has got many, after the introduction of the complex numbers, only then the theory of equations, so many equations could be solved in, and having complex roots, and its applications to geometry is much more. So you are very lucky that the government of Telangana is providing a very good opportunity. Not only myself, many experienced lecturers, they are participating in this program. So please avail this opportunity and get a benefit from this program. Today's topic is complex numbers, which comes under mathematics 2A, and this complex numbers has got a very good advantage in the field of geometry and also in the theory of equations, and especially the complex variable calculus is developed after the introduction of complex numbers only. Now we start the problems. Okay, right. Number 1. For any two complex numbers, Z1 and Z2, the number Z1 Z2 bar plus Z1 bar Z2 is 1. Pure imaginary, 2. Pure real, 3. 2 times real part of Z1 Z2 bar, or 4. 2 times imaginary part of Z1 Z2 bar. Okay, right. And I will give you the solution. See, any complex number Z is pure real or pure imaginary according as Z bar is equal to Z or Z bar is equal to minus Z. Okay, right. So now we'll take Z1 Z2 bar plus Z1 bar Z2. You take the whole bar and as per the conjugate laws, this is Z1 bar Z2 plus Z1 Z2 bar. Okay, but which is the given number? Is nothing but the given number. Given but is a given number. So therefore the given number is real. See, for any two complex numbers Z1 and Z2, the number Z1 Z2 bar plus Z1 bar Z2 is 1 pure imaginary, 2 pure real, 3 2 into real part of Z1 Z2 bar and 4 2 into imaginary part of Z1 Z2 bar. So and you know that any complex number Z is pure real or pure imaginary according as Z bar is equal to Z or Z bar is equal to minus Z. Now the given number bar is equal to Z1 bar Z2 plus Z1 Z2 bar, which is nothing but the given number, So therefore Z1 Z2 bar plus Z2 Z1 bar is pure real. Is pure real. So the answer is number 2. The number of complex numbers satisfying Z cubed is equal to Z bar is 1, 6, 2, 5, 3, 4 and 4 infinite. Right? Okay. Z cubed is equal to solution. Z cubed is equal to Z bar implies mod Z whole cubed is equal to mod Z bar, which is, and all of you know that, which is equal to mod Z. And you know that modulus of Z is same as modulus of Z bar is same as modulus of minus Z. So mod Z bar is equal to mod Z. So this is implies mod Z whole square is equal to 1 if Z is not, mod Z is not equal to 1. Or mod Z is not equal to 0. Mod Z not equal to 0. Okay? Right. But this implies that Z is equal to plus or minus 1 and Z is equal to plus or minus I. And of course, mod Z is equal to 0. Here you must be very careful. Here I have mentioned number of complex numbers only. But now I have not mentioned the number of non-zero complex numbers. So there are 4 already, plus or minus 1, plus or minus 4, and Z is equal to 0 is also a root. And Z is equal to 0 is also a root. So therefore, number of complex numbers is 5, but number of non-zero complex numbers, zero complex numbers is 4. So what you have mentioned is number of complex numbers only. So therefore the answer is 5. 4 plus 1, 5 itself. So let us recall the number of complex numbers satisfying z cubed is equal to z bar is option number 1, 6, 2, 5, 3, 4 and 4 infinite. Now z cubed is equal to z bar implies mod z cubed is equal to mod z bar, which is mod z, and that implies mod z square is equal to 1 if mod z is not equal to 0, and which shows that mod z is equal to plus or minus 1 and plus or minus I, and z is equal to 0 is also a root. So therefore the number of complex numbers is 5, but number of non-zero complex numbers is 4. So you must be very careful in reading the problem. So the student must have very carefully read the problem, whether it is non-zero complex numbers or complex numbers only. Non-zero, if it is non-zero, then answer is 4 complex numbers. If he mentions complex numbers, 0 also will be included. 0 also will be included itself. Right. Now we will do next go to problem number 3. If x plus iy is equal to square root of 3 plus I by 3 minus I, say 1 plus 3i, 1 plus 3i, then x square plus y square whole square equals 1, 2, 2, 4, 3, 2 by 3 and 4, 1. Right. And now squaring both sides of the given equation. Now squaring x plus iy whole x plus iy, we have x square minus y square plus I into 2xy is equal to 3 plus I by 1 minus 3i. So now you know that how to realize the denominator. So 3 plus I into 1 plus 3i by 1 square plus 3 square. So this is, so 3 into 1 3 minus 3, 3i into I, or I will write 3 plus 9i plus I minus 3 by 10. So now plus 3 minus 3 will cancel. So this is simply 10i by 10, which is equal to I. Now equating real and imaginary parts. Now equating real and imaginary parts, we have x square minus y square is equal to 1 and x square minus y square is equal to 0 and 2xy is equal to 1. Now you can see that is 2xy is equal to x. 2xy is equal to I. Is not. So this shows that either x is equal to plus or minus y and 2xy is equal to 1. 2xy is equal to 1 itself. Okay. So the given hypothesis is x plus iy is equal to root over 3 plus I by 1 plus 3i. Now squaring both sides, x square minus y square plus I into 2xy is equal to 3 plus I by 1 plus 3i. And this is equal to, you know that realizing the denominator, 3 plus I into 1 minus 3i by 1 plus 3 square. And this is, you can write 3 minus 3 into I square is minus 1. So therefore 3 plus 3 and minus 9i plus I. So minus 8i by 10. So which is equal to 6 minus 8i by 10. 6 minus 8i by 10. So therefore equating the real and imaginary parts, what you will get is x square minus y square is equal to 6 by 10, which is 3 by 5, and 2xy is equal to 8 by 10, which is equal to 4 by 5. Okay, right. Now you know that x square plus y square whole square is equal to x square minus y square whole square plus 4x square y square. And but x square, you know that x square minus y square is equal to 3 by 5. So this is 9 by 25 plus, and you are given 2xy is equal to 4 by 5. So which is 16 by 25, which is equal to 1, which is a 1. So the answer is 4. X square plus y square whole square is equal to 1. Okay, now we will go to the next problem. Problem number 4. If b is greater than 0 and z is equal to b plus 2i, right, and z into mod z minus bz plus 1 equal to 0, then number 1, z is pure imaginary and 2, no such b exists. no such b exists. 3, b square is equal to 2 root 2 and 4, b square is equal to 2. Right. So now the given equation substituting the value of z in the given equation, b plus 2i into square root of b square plus 4 is equal to b into b plus 2i minus 1. b into b plus 2i minus 1 itself. Right. Now again equating real and imaginary parts, so we have b into square root of b square plus 4 is equal to b square minus 1 and 2 into square root of b square plus 4 is equal to 2b. Now the second equation gives b square plus 4 is equal to b square. 2 will cancel, b square plus 4 is equal to b square, which is absurd. So therefore, no such b exists. So the answer is 2. So we will go to the next problem number 5. If z is complex and I z cubed plus z square minus z plus I is equal to 0, then mod z is equal to 1, 2, root 2, 3, 2 and 4, 1 by 2. And all of you know that minus 1 is equal to I square. So that the given equation can be written as iz cubed plus z square plus I square z plus I is equal to 0, because I square is equal to minus 1. So that implies if you take z square common from the two terms, z square into iz plus 1 plus I into iz plus 1 equal to 0. So that implies Iz plus 1 into z square plus I is equal to 0. So in any case that implies either z is equal to minus 1 by I, which is I, or z square is equal to minus I. So in any case, therefore, in any case, mod z is equal to 1. In any case, mod z is equal to 1 itself. So the answer is number 1. So we'll go to the next problem, number 6. Omega not equal to 1 and omega cubed is equal to 1. And theta is equal to omega power 10 plus omega power 23, omega power 23 into pi minus pi by 4, then sin theta value, then sin theta is equal to number 1 minus root 3 by 2, minus 1 by root 2, 3, 1 by root 2 and 4 root 3 by 2. And we know that omega cubed solution is omega cubed is equal to 1 and omega not equal to 1 means omega is non-real cube root of unity so that and omega power 10 is equal to omega power 9 into omega, which is equal to omega, and omega power 23 is equal to omega power 21 into omega square is equal to omega square, So therefore, theta is equal to omega plus omega square into pi minus pi by 4. But we know that it is known that 1 plus omega square is equal to 0, because omega is a non-real cube root of unity. So and everybody knows that 1 plus omega square is equal to 0. So that theta is equal to minus pi by 4, which is minus 5 pi by 4. So and hence sin minus 5 pi by 4 is equal to minus of sin 5 pi by 4. So which is minus of minus 1 by root 2. Minus of 1 minus 1 by root 2. So which is 1 by root 2, which is 1 by root 2. That I need to put. Because minus of minus is a plus always. So the answer is 3, 1 by root 2. See, especially in the Eamcet level or in mathematics, that is in the complex numbers, the cube roots of unity is very important property, and everybody knows that if omega is a non-real cube root of unity, then 1 plus omega square is equal to 0 and omega cubed is equal to 1. So because this omega in all the Eamcet levels, definitely ప్రతి సంవత్సరం కూడా ఈ క్యూబ్ రూట్స్ ఆఫ్ యూనిటీ మీద ఖచ్చితంగా ప్రాబ్లం ఉంటుంది, మెయిన్లో కూడా ప్రాబ్లం ఉంటుంది. సో దట్స్ వై ఐఎమ్ వర్కింగ్ అవుట్ సో ఏ గుడ్ నెంబర్ ఆఫ్ ప్రాబ్లమ్స్ అండ్ క్యూబ్ రూట్స్ ఆఫ్ యూనిటీ. If n is not a multiple of 3, not a multiple of 3, then the value of minus 1 by 2 plus I into root 3 by 2 whole power n plus minus 1 by 2 minus I root 3 by 2 whole power n is equal to number 1 0 2 minus 1 3 1 and 4 2 power n, right. And just now I told you the property of the cube root of unity. And you know that minus half plus I root 3 by 2 and minus half minus I root 3 by 2 are omega and omega square respectively. So that omega and omega square respectively, so that omega cubed is equal to 1 and 1 plus omega square is equal to 0. 1 plus omega square is equal to 0. So therefore, the given number is equal to omega power n plus omega square whole power n, which is omega power n plus omega power 2n. Now it is easy to check that 1 plus omega power n plus omega power 2n is equal to 0 or 3 according as n is not a multiple of 3, not a multiple of 3 or multiple of 3. Multiple of 3. So therefore, and in the given problem, n is not a multiple of 3. N is not a multiple of 3. So that 1 plus omega power n plus omega power 2n is equal to 0 or omega power n plus omega power 2n is equal to minus 1. Omega power n plus omega power 2n is equal to minus 1. So option number 3, answer is option number 2. Answer is option number 2 itself. And this is I am reminding you that this is a very important property of this. Of course, if possible, I will bring this problem, this as a, in the later stage, I will give this as a problem itself. Understand? Because on this property, in once one problem is asked, based on this property of the complex numbers, that is cube roots of unity. Problem number 8. We will come to the problem number 8. If x square plus x plus 1 is equal to 0. Then the value of sigma x power k plus 1 by x power k is equal to 1 to 27. 1 to 27 is 1, 54, 2, 27 and 3, 8, 18 and 4, 9. Of course, this is a very good problem which is asked in so many competitive examinations like KVPY and mains, and of course previously IIT also, the same problem. And Indian National Olympiads also this was asked, of course, some 50 years back. So now the solution is so x square plus x plus 1 equal to 0 implies x is equal to minus 1 plus or minus square root of 1 minus 4 by 2. So which are nothing but minus of plus or minus I root 3 by 2. So which are nothing but omega and omega square, cube roots of unity, omega and omega square, that is cube roots of unity. Okay, so therefore now we can have that is, so therefore x power k plus 1 by x power k is equal to, I think, whole square, this is whole square, is equal to 1 plus 1 is equal to 2 if k is a multiple of 3, that is if k is equal to 3, 6, 9, 12, etc. up to 27, and x power k plus 1 by x power k is equal to minus 1 for k is equal to 1, 2, 4, 5, etc. up to 26. So therefore the given sum is equal to 2 plus 2 square plus 2 square plus 2 square etc. 2 square 9 times, because there are only 9 integers are there between 3 and 27, multiples of 3. The multiples of 3 between 1 and 27 are simply 3, 6, 9, 12 etc. whose number is 9. This number is 9 itself, and the rest 18 are non-multiples of 3, then that is equal to plus 1 plus 1 plus 1 etc. 1 18 times. So which is 4 into 9 plus 18, so which is 54, which is equal to 54. So please carefully see that is this k value is k is equal to 1 to 27. That means the sum is contains x plus 1 by x plus x square plus 1 by x square plus x cubed plus 1 by x cubed plus x power 4 plus 1 by x power 4 etc. x power say 27 plus 1 by x power 27. So among those, multiples of 3 are 9 and the rest are non-multiples of 3. For multiples of 3, the given expression is whole square is 2 plus 2 plus 2 9 times. which is 36. And the rest 1 plus 1 plus 1 18 times, which is 18. So therefore the total number is, sum is simply 36 plus 18, which is 54. So the answer is number 1. If x square plus x plus 1 equal to 0, then the value of sigma x power k plus 1 by x power k whole square, k runs from 1 to 27, is, so first number 1 option 54, 2 is 27, 3 is 18 and 4 is 9. And we know that x square plus x plus 1 equal to 0 means x is equal to minus 1 plus or minus square root of 1 minus 4 by 2, which is nothing but minus of plus or minus I root 3 by 2, and they are the cube roots of non-real cube roots of unity. For a non-real cube roots of unity, just I have mentioned that if n is any integer, 1 plus omega power n plus omega power 2n is equal to 0 if n is not a multiple of 3, and 3 if n is a multiple of 3. So here this is simply, so 2 plus 2 plus 2 plus 2, this is 2 square plus 2 square plus 2 square etc. 1, and this is again 1 plus 1 plus 1 18 times, so which is 4 into 9 plus 18 into 1, so which is nothing but 54. If k is a multiple of 3, x power k is equal to 1 if k is a multiple of 3. So this is, if this is omega x and 1 by x is omega square. So if omega plus omega square is equal to 1 plus 1 when k is a multiple of 3. K is a multiple of 3. So that's why I got here 1, k, x power k plus 1 by x power k is nothing but 1 plus 1 is equal to 2. When k value is 3, 6, 9, 12 etc. up to 27. That means all those are all nothing but multiples of 3. 3 into 1, 3 into 2, 3 into 3, 3 into 4 etc. 3 into 9. So this number is, how many numbers are there? 9 numbers. So you get 2 square I am writing. So 2 square plus 2 square plus 2 square 9 times. So that is 4 plus 4 plus 4 9 times 9 into 4. And the rest is 1 plus 1. That's why I have written square means, if I don't write square, then you will get 2 plus 2 plus 2 9 times and minus 1 minus 1 minus 1 18 times you will get. Only to get a positive integer, so we have written that squares, x power k plus 1 by x power k whole square. Now we will go to the problem number 9. If omega not equal to 1 is a cube root of unity, is a cube root of unity, is a cube root of unity, then the value of of 4 plus 5 into omega power 334 plus 3 into omega power 365 is 1 minus I root 3, 2 I root 3, 3 minus 1 plus I root 3 and 4 minus I root 3. Okay? Right. And why I am stressing on the cube roots of unity, you will certainly get a problem in any competitive examination or Eamcet or mains on this. So that's why, so that you can remember the properties of the cube roots of unity. So now we know that omega is equal to minus of plus I root 3 by 2 and omega square is equal to minus of minus I root 3 by 2. Wait. Now, and you know that omega cubed is equal to 1. So, therefore, 4 plus 5 omega to the power of 334 plus 3 into omega power 365 is equal to 4 plus 5 into omega power 333 into omega plus 3 into omega power 363 into omega square. This is just a theory of indices. A power m into a power n is equal to a power m plus n. So, this is nothing but 4 plus 5 into omega power 333, which is nothing but 1, because omega cubed is equal to 1. And also omega power 363, that is also 1, because omega cubed is equal to 1. So, this is nothing but 4 plus 5 omega plus 3 omega square. And that is, if you take 3 outside, 3 into 1, 3 if you take outside, 3 into 1 plus omega square. Now see, 5 omega is there, 3 omega, so 2 omega is left behind, 3 omega square is there, and 4 is there, but here if you multiply you will get 3. So you can write that is 1 plus 2 omega, 1 plus 2 omega, and you know that this is 0, so that is nothing but 3 into 0 plus 1 plus 2 omega. So which is 1 plus 2 omega, which is nothing but 1 plus, so 2 into minus 1 plus I root 3 by 2. Minus 1 plus I root 3 by 2. So 2 will cancel. So plus 1 minus 1 will cancel. So this is nothing but I root 3. That value is nothing but I root 3. Now we will go to the problem number 10. If x is equal to minus 5 plus 4i, minus 5 plus 4i, then the value of, see sometimes these type of problems are being asked, value of x power 4 plus 9x cubed plus 35x square minus x plus 4 is equal to 1 0 to 151 3 minus 150 and 4 minus 160. Okay, right. Now x is equal to solution, x is equal to minus 5 plus 4i implies x plus 5 whole square is equal to minus 16, is equal to minus 16. So therefore, so that indicates x square plus 10x 25 plus 16 plus 41 is equal to 0. X square plus this x square plus 10x plus 25 plus 16, so 41. So x square, this value is simply x square plus 10x plus 41, that is 0. Now we can write Now the given expression x power 4 plus 9x cubed plus 35x square minus x plus 4 by actual division method, which you know in the 8th class and 9th class level. So this can be written as x square plus 10x plus 41 into x square minus x plus 4 minus 160. Minus 160. This is by actual division method, division of expression, synthetic division R. So therefore, see, sometimes when you are given asked problems of this type, what you do is you simplify the given expression and try to divide the required expression by the given expression. Then you get a remainder. You will get a remainder. That is the answer. So now this is 0 into x square minus x plus 4 minus 160. So the answer is minus 160. Because x square plus 10x plus 41 is equal to 0. So the answer is number 4. We will take up problem number 11 itself. 11. If omega not equal to 1 is a cube root of unity, then the least positive integer such that 1 plus omega square whole power n is equal to 1 plus omega power 4 whole power n is number 1, 2, 2, 3 and 3, 4 and 4, 6. Of course, this is asked in so many competitive exams. So now the solution is, and you know that 1 plus omega square is equal to 0 and omega cubed is equal to minus 1. 1 implies this is 1 plus omega square is minus omega given expression, implies 1 plus omega square whole power n plus 1 plus omega power whole power n is equal to minus omega whole power n plus minus omega whole power n. Minus omega whole power n is equal to, is equal to, please see, 1 plus omega square is minus 1 and 1 plus omega power 4 is omega. So 1 plus omega means omega square. So that implies minus omega power n is equal to minus omega power 2n. So the least positive integer is nothing but n is equal to 3. When n is equal to 3, this is minus 1 and this is also minus 1. So therefore least positive integer n is 3 because omega cubed is equal to 1. The least positive integer n is 3. So the answer is 2. See, you are given that 1 plus omega square whole power n is equal to 1 plus omega power 4 whole power n. But 1 plus omega square is equal to minus omega from this. And omega power 4 is omega. So this is 1 plus omega. So 1 plus omega is minus omega square. Minus omega square. So that's why what you will get is, this implies minus omega power n is equal to minus omega square whole power n. And that is possible when n is, the least positive integer n is simply 3. Because when n is equal to 3, this is minus 1 and this is also minus 1. Both are equal. Both are equal. Problem number 12. This is also, if omega not equal to 1, this is once asked in mains also, is a cube, mains and Eamcet, is a cube root of unity. Is a cube root of unity. And 1 plus omega power 7 is equal to a plus b omega. Then ordered pair a comma b is equal to number 1 comma 0, 2 minus 1 plus 1, 3 0 1 and 4 1 comma 1. Right. And again we use the property of cube roots of unity. Now 1 plus omega is equal to minus omega square implies 1 plus a plus b omega is equal to minus omega square whole power 7, minus omega square whole power 7. So which is minus omega power 14, which is equal to minus omega square whole power 7, which is minus omega power 14, because minus of omega square, minus of odd power is minus, so minus omega. So therefore minus omega means a is equal to 1 and b is equal to minus 1. 1 plus omega power, 1 plus omega is equal to minus omega square. So therefore the given one a plus b omega is equal to minus omega square whole power 7. So there is minus omega power 14, which is actually omega power 12 into omega square. So which is equal to minus omega square. And 1 plus omega square, 1 plus omega square is equal to 0. And here a plus b omega is equal to minus omega square. That a plus b omega plus omega square is equal to 0. This implies a is equal to 1 and b is equal to 1. A is equal to 1 and b is equal to 1. So the answer is 4. You know that this is, everybody knows this one. Now what we got is a plus b omega plus omega square is equal to 0. So then a should be 1 and b should be 1 itself. So a comma b is equal to 1 comma 1. So my dear students, in this 1 hour program we did 12 problems, out of which more are on cube roots of unity. Thank you.